So this is going on again on page 50. Law of cosines. Just like law of sines is used when you have oblique triangles. Obliques are called non-right triangles, okay? So triangles without a right angle. You don't need to write that down. You already have written that down at some point for law of sines. Law of cosines is what you can also use for non-right triangles to find side lengths and angle measures. And just like how I talked about yesterday, when you have a triangle, capital letters represent the angles and lowercase letters represent the sides. We talked about that on Monday as well. What is the law of cosines? Well, it is this reddish color paper that you guys got. It is this formula of a squared equals b squared plus c squared minus 2bc cosine A. Now realize that the other two formulas that are on here are basically the exact same thing.
Just whichever angle you have or side.
But it just switches whatever side you're looking for. So if you're looking for side B, then it'll be b squared equals a squared plus c squared minus 2ac cosine B. If you're looking for C, then it's c squared equals a squared plus b squared minus 2ab cosine C. Yes?
So we're going to have to memorize all the formulas that we get? Or?
You're just going to have, to be honest, all you have to do is memorize this one. But as for knowing law of sines and law of cosines, yes, you will need to memorize those formulas.
Oh, we need to write those down?
No, they're on the paper. All right? So, these are the formulas. When do you use law of cosines in comparison to law of sines? Well, you use the law of cosines in two cases. The cases are what's on this green sheet. Case one is when you have two angles and an included side. In other words, side, angle, side. That is case one that's on your paper. Or when you know all three sides. That is the side, side, side situation. Okay? So you use law of cosines for these two. You pretty much use law of sines for any other situation. Any questions?
Is there a law of tangents?
There is no law of tangents. Okay? Just law of sines and law of cosines.
I was going to have to know the inverse.
What do you mean?
Like, you know how in sine we had to use the inverse to find
Law of inverse sine.
It's the same thing when if you're looking for an angle instead, then whatever angle you're looking for is the formula that you use. So like if I'm looking for angle A, I'll use the first one. And then I basically just need to get cosine A by itself and yes, take the inverse. Whenever you're looking for an angle, you'll end up taking the inverse. Okay? So let's start with our first example. All right? Let's get this example down. We're going to solve this triangle ABC. What does it mean to solve?
Find every side.
Find every side, find every angle. We know two sides already, so that means we're looking for one more side. And we know one angle, so that means we need two more angles. Okay? Yes, you are handwriting this. Okay? So, to solve this triangle, we need to figure out a side or an angle. Since this is a side angle side situation, we want to start by using law of cosines to find which piece of information. Side C. Okay? We're looking for side C. And we can't really find anything else because we don't have enough information. So if I'm looking for side C, that means the formula is going to be c squared equals a squared plus b squared minus 2ab cosine C. Now I'm only writing the formula so you guys can see where all the numbers are getting plugged into for this example. The next example, I'll probably just plug the numbers straight in. So, what's A? What's lowercase a? 16.
Oh.
If you put 10 first, it's fine to make sure that 16 follows. What's b squared? 10. So you square that. Minus 2. What do you think AB mean? What are you going to do? Multiply. So that's 2 times 16 times 10. And then since it's attached to the cosine, what are you doing with the cosine as well? Multiplying angle C. Now at this point, we go to our calculator and we type this in.
Are we supposed to times it by C? At the end where it says cosine 110?
No, that cosine 110, angles are, trig functions are always attached to angles. So when you do cosine, it's cosine of that angle. A parenthesis always pops up whenever you type the trig function. Uh-huh.
Does that involve plus or minus?
You see that? Well,
Yes.
it does, but because we're talking about side and lengths,
It has to be positive.
it has to be constant. Okay? Do we all have it in?
Yes.
And we always want to double check, especially if you're using one of my calculators, you're in degree mode. So let me go back and check. I am in degree mode. If you're not, all you do is go down, make sure degree is highlighted by clicking enter. So I'm going to click enter to see what I get, and I get this large number. Did everybody get this number?
Yep.
So c squared equals 465 point something. But I'm solving for c, so what do I need to do? So I'm going to square root this number that's in my calculator. Second x squared. And I'm just going to do second negative 1. It takes the whole thing. That ANS means the answer, the previous answer. So it's going to be 21.6. You guys get that?
Yes. Yeah.
So C is 21.6. Well, if you think about it, plus or minus, C represents the side length. Can we have negative side lengths?
No.
So it's only going to be the positive.
And that formula is so long, I already know how you figure something out. I'm just happy to.
Now let's find the angles. Okay? Now that I know C is 21.6 and some change, of course, I can do what?
Use law of science.
I can definitely use law of sines. Yes, you can mix and match them, okay? However, when you first start a problem off, you're going to have to use one or the other, okay? But once you find another piece of information, you can, mix and match them. Let's use the law of sines. So that's going to be that 21.6 number over
Sine 110.
equals, which angle you want to find?
16.
Let's find A first, okay? So it's going to be what on top?
16 over sine A.
Whenever I'm looking for an angle, I'm going to have to do what?
Inverse.
Inverse. So, after I cross multiply and I start dividing, I'm going to take the inverse at the very last step, okay? So, cross multiply, that's going to be 16 sine 110 equals 21.6 sine A. What am I going to do? And then take the inverse of sine. Now, we have all this stuff, so, some of you have already started typing, so I don't know what you may have now in your calculator. But I haven't touched my calculator since the last part of the problem. If you cleared it, it's okay. You can use the rounded answer. For those who want that more precise answer, you see how I still have that 21.6 number in my calculator? I'm basically going to type in this whole fraction that's in the blue. 16 sine, there we go, 110. I'm going to divide that by my 21.6 number that's not rounded. Second
Oh, I still have answer.
negative pulls my previous answer, which was that 21.6 number. When I click enter, I get a decimal. I still have to take the sine inverse of it. Could I have done it all in one line? Yes. But I didn't want to make any mistakes, so I just did it separate. Second negative pulls the previous answer. So you should have gotten 44.2.
You got 0.7. I got 1.4. Because you used
Depending on, that answer button can only be used for, the previous answer. So if you accidentally type in something else, it's going to pull the last answer that you asked it to calculate.
Oh, yeah.
So angle A is 44.2. Now someone may ask, Ms. Anderson, can I just use the rounded answer? Yes, you can use the rounded answer. However, just realize that your answer may be a little bit further off from mine. Not too much further, nothing too ridiculous, but it'll be all right. One way you can kind of let me know which number you're using is by doing what I just added in. 3 dots. That lets me know you're using the non-rounded answer to find your final answer. 2 angles down. 1 to go. How do I find it? So what is angle B? Questions?
Where did you get 44.2?
That's when we found angle A. So we are done with this problem. We have solved the triangle. Well, before we get to the other situation, I want you guys to try this one on your own. I want you to try this one on your own, so I make sure you guys understand the side angle side way first before we get to the other situation. So work on this one on your own. Give you about 5 minutes, then I'll check in. The longest side should be across from your largest angle. Out of angles A, B, and C, which one was the largest angle?
B.
B. With 77, right?
Yeah.
So that meant that side B needed to be the longest side. Was it?
Yes.
Okay. And if you're saying that B is the longest side, then that means that C, which is across from the shortest side, should be the smallest angle. So hopefully you guys set it up as B squared equals 8 squared plus 5 squared minus 2 times 8 times 5 cosine 77. When you did all that, you got a number, right? 71 is something? Then you took the square root of that? 8.42?
43.
If you round that up, but let's go 10. So 8.4, right? So then, once you found that, which angle did you find next?
Okay.
C.
Well, whether you found C or A, you still needed B and angle B to figure out C or A. I think I found C next. Really doesn't matter which one you find. It should still be the same thing no matter which one you do. Okay? So, if I wanted to find A, I would be 8 over sine of A equals that number over the sine of 77, yes? Cross multiply. And then,
Inverse of sine.
They give you 67.7.
Whoa.
I think it's
I got 67.
I got 35.
Wait, I got 6.
wait, I'm talking about
Oh.
angle A.
Yeah.
So it should be 67 point.
Oh, yeah.
Six.
My calculator is 67.67, so 6.7.
What?
That's right, I said it.
I got
Now.
68.
Oh, maybe I did.
I got the same thing that you got. I got 67.7 because I used that long decimal. Like I just carried that number down using the second negative option. I got 67.7. Now, if you got 67.8, that just might mean that you used maybe the exact number, which is fine.
I got 68.
But just show me that.
I got 64.9.
I got 67.6.
Might have been a number. Maybe you accidentally typed in like, I don't know, sign of 76 instead of 77.
Oh,
No.
I put 70. I put 72.
Okay. It doesn't matter which of the formers you use because technically they all are saying the same thing. Whatever side you're looking for, you take the 2 sides you know, square them and add them together, and then subtract 2 times the 2 sides you know, cosine the angle that you know. All of them say the same thing. Okay? They all say the same thing. Let's finish this one up. To find angle C, I just take 180 and subtract it from the 2 sides that I do know. And so C should have been what?
35.3.
Just make sure that all three angles should add to be 180.
I arrived at so maybe my
Yeah, ours equals.
And just make sure you show me what you're using. Me, I put the dot, so that lets you know that I'm using the full one. Okay? Let's look at the ones where you are given side, side, side. Okay, let's look at the ones where you're given side, side, side.
Can you do
Would it be enough space?
Yeah.
Could you tell the sarcasm? Is this supposed to be the example I was supposed to learn? The last example of this cookie?
Yeah. Like this will be our last example that we do. Okay. So your side, side, side situation. Okay. Now, this one's a little different. You know all your sides. So that means you're just looking for your angles. Not too different because I'm still using the same formula. Okay? Not too different, I'm just using the same because I'm using the same formula. Except this time, instead of it being a squared equals everything, you'll have a number plugged in for a squared, and then the angle will be missing. Okay? Which angle do you want?